Hi everyone, this is Mr. Short. Today we're going to be talking about the evolution of atomic theory. And by evolution, what we mean is the way that atomic theory, our understanding of it, has changed over time, because to evolve means to change. So we'll ask the question, how have atomic models changed over time? And in particular, we're going to be looking at the contributions of four individuals. Those are Democritus, an ancient Greek philosopher from about 400 BC, John Dalton. He came along in the early 1800s, and he was the first scientist to make important contributions to atomic structure. J.J. Thomson in 1897, and then Ernest J. Rutherford in about 1911. First, let's get a better understanding of what a model is in science. You might be familiar with this model. This is a model of the atom, and you can see that it's got the nucleus, which is small and dense in the center. It's got all of these electrons that rotate around on particular orbits around the outside. So a model uses a familiar idea to explain unfamiliar facts that are observed in nature. In particular, I want you to know that a model can change over time as new information is collected. And that's often what happens in science. We perform new scientific experiments, gain new information, and change the model to better represent all of the science that we understand. Here's an earlier look of a model of the atom. The atomic model, it has changed throughout the centuries. Starting in about 400 BC with Democritus, as we're going to see in a minute, Democritus might have thought that an atom looked like a billiard ball, in that a billiard ball or a pool ball would be solid. So Democritus, again, ancient Greek philosopher, he did thought experiments attempting to describe the structure of matter about 2,400 years ago. He asked the following question: could matter be divided into smaller and smaller pieces forever, or was there a limit to the number of times that a piece of matter could be divided? His theory, once he did this thought experiment, was that matter could not be divided into smaller and smaller pieces forever. Eventually, the smallest possible piece would be obtained, and this piece would be indivisible. And that concept of an atom being indivisible is a really important concept. He named the smallest piece of matter atomos, meaning not to be cut. So he believed that an atom could not be cut. This is a model of Democritus' understanding of matter at the time. To Democritus, he believed that atoms were small, they were hard particles, and they were all made of the same material. Just meaning that all gold atoms would be exactly the same as all other gold atoms. All aluminum atoms would be the same as all other aluminum atoms, but gold and aluminum atoms would be different. Democritus also thought that atoms are in constant motion, as you can see in the figure to the left, in the animation to the left, and that they're capable of joining together, just meaning that they could bond together in different bonding arrangements. So let's pause now and take a look at a timeline of atomic theory. We just took a look at the Greek model proposed by Democritus about 2,400 years ago. And in just a minute, we're going to fast forward to Dalton's atomic model, which comes along in about 1803. And then in a separate video, we're going to take a look at Thomson's model, called the plum pudding model, in 1897, and in Rutherford's nuclear model of the atom, which he proposes in about 1911. So I want you to know that Dalton was the first scientist to study atomic structure. And in the early 1800s, the English chemist John Dalton performed experiments that eventually led to the acceptance of the idea of atoms. Four things that I want you to know about Dalton's atomic model. And as we talk about these, I want you to notice the similarities between Dalton's atomic model and the model proposed by Democritus about 2,200 years before this. Point number one, elements are composed of tiny, indivisible particles. Right? And that relates back to the concept of atomos, meaning indivisible or cannot be cut. Point number two, atoms of the same element are alike in terms of mass and size. Point number three, atoms of different elements are different in terms of mass and size. And point number four, compounds are formed by the union or joining of atoms of two or more elements.